So today I'm going to talk to you guys about more about what I do on a daily basis, and then I am going to tell you guys about like how the biotic ligand model is incorporated into the permitting system. So NPDES is the National Pollutant Discharge Elimination System. MSGP is the permit that I work on, the multi-sector general permit, and then the BLM is biotic ligand model. So this is generally like how they're all tied together. First, I have to say that I'm here in my own capacity. I'm not here in any official EPA capacity. So anything that gets said here is basically, that's my own voice, right? My opinion, it's not anything official from the agency. So if you happen to work for anybody that works with the agency, please don't go back and say like, oh, well, Alicia said in this class Monday that this is what the agency does and this is what the agency says. So generally I'm gonna go through kind of the regulatory structure, starting from the bottom, right? Like you build a good house. We'll talk about kind of the Clean Water Act, and then the regulations that are in the Code of Federal Regulations, and where the permit that I'm working on kind of comes from, and then the actual permit that I'm working on. And then I'll talk about the biotic ligand model. So the Clean Water Act is actually a set of amendments that were amending I gotta get this right, Federal Water Pollution Control Act. So this incident is really what called attention to the pollution in our waters in the United States. So in 1972, they passed the Clean Water Act that gave kind of the federal government a little bit more power over regulating what goes into our waters, and the objective was to restore and maintain the chemical, physical, and biological integrity of the nation's waters, or the waters of the United States, as you might hear referred to. The goal was to eliminate the discharge of pollutants and to ensure the waters are safe for aquatic life and recreation. So there's actually ties back to like ensuring that these waters are safe for aquatic life and recreation as part of the permitting regulation. You'll see that the waters have to kind of be defined as like for a purpose, right? And that's part of the requirements in permitting. So the NPDES permit program, which is established by Section 402 of the Clean Water Act. So you'll hear, Section 402, Section 401, Section 301. When people say that, generally they're referring to the Clean Water Act. When Congress passes an act, it gets codified in the U.S. Code, which really separates it all up and gives you a bunch of numbers that nobody really references. But in case you ever come across that, that's pretty much what happens. Usually these are referred to as like Clean Water Act sections. And you can find this online. It's actually really kind of fun to read sometimes. But it sets the Section 402 establishes the NPDES permit program. It sets a permit term of 5 years. And the permit is considered kind of a shield for dischargers, right? So like if you're complying with your permit, then you're more protected than if you aren't, right? It also established the ability to authorize states for their own NPDES permitting programs. So right now there are actually only 3 states that don't have their own authorization to like permit under NPDES. It also established technology and water quality-based requirements. We'll talk about that in a second. And then there are significant penalties for permit violations, and there's a specific definition for violations. So first, the NPDES statutory regulatory framework kind of says that all point sources that discharge pollutants into waters of the United States must obtain an NPDES permit, right? So like you drive a car, you can't drive a car without a permit or without a license, similar to this, right? So the CFR and the Clean Water Act will actually define a lot of things that come into play here. So it'll define point source, right? So point source, we're all pretty familiar with this term. It's a little bit tricky sometimes, but is any discernible, confined, and discrete conveyance of water into the water of the United States. So that can be any pipe, ditch, tunnel, conduit. Basically, like, if you see water flowing in like a confined, like, very distinct flow into waters of the United States, which then is considered a point source. It does not include like your return flows from irrigated agriculture or agricultural stormwater. There's very separate, like, it's very like clear that that's not included under the permitting program. And then a pollutant is defined as anything that can change the physical, chemical, or biological characteristics of the water, including heat. So one of the things that we oftentimes monitor for is temperature. And there are in certain waters, in certain water bodies, there are like very strict regulations on temperature. So usually, like, either EPA or a state, I don't know if there are any like territories or tribes that have authorization to administer the NPDES program, but that's usually how it works. So EPA doesn't issue all NPDES permits. EPA does give authority to certain states if they can prove that they have to establish their own water quality standards, and they have to kind of come up with a plan to regulate waters, and then EPA approves it. So recently we went through this with Idaho, and some parts of like Texas, and also EPA maintains the authority to like take that back. So oftentimes, not oftentimes, but you will see kind of petitions from citizens or from NGOs that will ask EPA to revoke authority from a state. That rarely happens, but there's usually an investigation involved to like kind of figure out why. Okay. That stops working.
Freezed.
So this is kind of a map of the states that do have authorization, and you can see here, there are also like different levels of authorization, but that's not reflected in this map. So there are different pieces of the NPDES program that a state can be authorized for. So you see like here, New Mexico, Massachusetts, New Hampshire, and the District of Columbia, as well as these territories. Oh, I take that back. The Virgin Islands are actually authorized to like permit their own NPDES permits.
What's the problem with Massachusetts?
What's the problem with Massachusetts?
Yeah, they're normally on top of things.
They are actually on top of things, and I don't know if there's a plan for them to get their own authorization.
Maybe they don't want it.
There's actually like, when I talk about this general permit, there's a provision in the Clean Water Act that provides for the states to like add conditions to a general permit, and Massachusetts usually adds conditions. That's this whole long list of conditions, and like it's very complicated, and it makes everything that we did in our general permit like there are things that we have to think about, and we don't like. But Massachusetts, they are like really good, and their regional coordinator for Region 1 in Massachusetts and New Hampshire is really thorough. So when it comes to like looking at the facilities that are covered and making sure that we are programming into our like electronic systems the conditions for Massachusetts and New Hampshire, he's like really thorough, and he makes sure that there's actually the example that I have later is from a facility in Massachusetts.
And one question, just because they're authorized doesn't mean like they are fully doing whatever EPA is saying, right? They're defining their own thing.
Right. So just because they're authorized doesn't mean that they have to do like exactly what you said, like what EPA is doing. So about 50% of the state, like of the authorized states, will kind of follow exactly what we write in our MSGP. Some of them will add more stringent conditions. Some of them kind of change the structure. So like, for example, the permit that I'm working on, this MSGP, it's one permit that covers like 29 different sectors. The state of Alabama actually has like different permits for each of those sectors. But they're allowed to issue those permits as long as they maintain the water quality standards and it's not less stringent than federal regulations.
So there is a base.
Yeah. And we get that question a lot because actually I gave a presentation to the Treated Wood Council and they asked that question. Like there's a lot of states kind of doing their own thing, which is allowed. Like, you know, Clean Water Act that's set up and says states can do that, right? And the EPA has like oversight, so we will do what's called a permit quality review where for the individual permits that I'm about to talk about, like EPA, the regional offices will review the individual permits to make sure that they are like in alignment with EPA's kind of like protections, if that makes sense. So to set this up, like the NPDES permit like program, it doesn't necessarily establish the difference between individual and general permits, but this is really kind of like practice. And the CFR is not really written for general permits, so oftentimes it's really hard. But for a nation this size, for the amount of facilities that we cover, for the amount of municipalities that we cover, we oftentimes will write a general permit. So the difference, like an individual permit is typically used when it's facility-specific permit conditions that are required. So you'll see that sometimes in like an impaired water or a facility that just like was discharging a lot of pollutants, and we said, no, you can't get coverage in this general permit anymore because you need more oversight kind of thing. There are varying conditions in which you need an individual permit. I think actually the states will issue more individual permits than EPA does. But the process for that is that a facility or a municipality, an individual permit application is like submitted. And then somebody will review it and say, okay, like you have to meet these requirements based on your facility, your activities, what you're discharging, and what you're discharging into, right? So for a general permit, it's kind of the other way around. We write the permit and we write the conditions and like on a nationwide level, and then facilities, in this case facilities, will seek coverage under the permit. And when they seek coverage under the permit, they submit what's called an NOI, Notice of Intent, and they then have to comply with the permit that we wrote at EPA headquarters. Or in some states they will write their own like general permits, right? So that's kind of how that works, and you kind of have to keep that difference in mind. So when we get to talk about the biotic ligand model, it's incredibly difficult for a general permit, but it's probably way more suited for an individual permit, and that's usually where you see kind of their like functionality of it. So currently there are about 50,000 individual permits, and there are almost 1 million general permits or facilities covered under general permits, and that includes, so we have the pesticide general permit, we have the vessel discharge general permit, we have the stormwater, which is like municipal, industrial, that's what I work on, and then there are some other ones that I'm not super familiar with. So the process for issuing a permit at EPA, so you have to keep in mind that this is government, right? We do things with the public. But normally we will prepare the draft and kind of why we want to like write the permit this way, why we want to include these certain requirements, why any changes that we're making, why we're making those changes. They usually have to be, for something like this, they usually have to have some sort of like scientific basis or economic basis. That can be anything from like, well, I'll talk about some of the changes that we made in this permit. One of them actually included the biotic ligand model. So, excuse me. So we draft the permit and then we release it for public comment. So if you ever decide you want to have fun on a Saturday, look up all these permits that are up for, not necessarily right now, but go into like regulations.gov and you can comment on any of the permits that are being written. There are lots of other regulations that are being written, right? But for our general permits, you can comment on them and say like, hey, I see that you only have one benchmark for copper. I think that you should be using the biotic ligand model. And then if there's like a lot of interest, we will sometimes hold a public hearing. I haven't been a part of that yet. Well, in pesticides, it was way more common, but for this, I haven't been a part of that yet. And then but normally we take all those comments, we kind of distill them down as different categories and figure out kind of really where the middle ground is, because you will have lots of environmental groups that are saying like you're not stringent enough, and then you have lots of industry groups that are saying you're too stringent. So EPA's job for the most part is to land right in the middle with something that's practical, but also protective. When I first started my job, people told me that if I was making everybody mad, I was doing my job well. So, and then we take all that, then we like put it together for a final permit, and then we issue the final permit. And then the permit will become effective, in which case like facilities have to seek coverage under that, or they have to get an individual permit, and then the whole process of like complying with the permit kind of starts. So usually a permit will contain like cover page, right? But that kind of explains, how to get coverage, so on and so forth. Effluent limitations. So we have technology-based effluent limitations and water quality-based effluent limitations. So like your technology-based effluent limitations are basically like, the best available like technologies to minimize these pollutants, right? So you can't necessarily say you have to have zero of this if the technology doesn't exist to have zero of this. So that's kind of one piece of these permits and how we control the pollutants that are discharged. And then you have water quality based. So those would be the things that say like you have to have like less than 5 milligrams per liter of whatever pollutant, right? And those are based on the water body into which you're discharging most of the time. And in order to like enforce those limitations, you have monitoring and reporting, right? So like you have to go out, take a sample, and make sure that your discharges are meeting those limitations, and then you have to tell EPA or the state like what your results were, right? And then you kind of have to report like there are also other aspects to a permit that will say like, you have to clean up, you have to sweep up so that all of like the solids aren't getting washed away when it rains, right? So you kind of have to like report on any of those type of things that you may have implemented or you found were not working well enough in an annual report. And then you will have special conditions and standard conditions. So like for this permit, most of our standard conditions are like 1 through 7. Everyone across the board has to do these things, right? But then you have special conditions for different sectors. So like sector A, which is like timber and like wood sectors, they don't necessarily have to comply. They don't have to monitor for the same pollutants that like scrap metal recycling has to monitor for. So those would be kind of like special conditions. So the 40 CFR 125.3A kind of gives you an idea of technology-based treatment standards that represent the minimum level of control that has to be implemented, like in accordance with the permit. So this is just one example. I'm not super familiar with these POTWs, but like for publicly owned treatment works, it will establish that you have to have a secondary treatment. And then for like industrial, like some of the technology-based like requirements are you have to have best practicable technology, best conventional technology, and best available technology. So, and there are definitions for those that I don't know off the top of my head, but if you really want to, you can look at the 40 CFR. And then they will also, in some cases, you'll see an effluent guideline. So, like, for example, in this case, there's an effluent limitation guideline for emulsions, so like asphalt emulsions. So if your facility deals with asphalt emulsions, when you monitor, you have to monitor for certain things, and if your monitoring results exceed those effluent limitations that have been established, then it's considered a permit violation. In which case, like, there are fines involved and other things that can happen. Like, they could revoke your permit, make you get an individual permit, which could be more stringent, so on and so forth, right? And then sometimes, I haven't seen this yet, but like if an ELG is not applicable, then they'll probably like make you apply for an individual permit, and then you kind of have to use your best professional judgment. So there's a lot of coordination with the state and with the region on an individual basis for these facilities. And then, so this is really what we've been learning about this class, right? Water quality standards. So your water quality standards will apply throughout the water body, or the part of the water body defined by the state, territory, or tribe. It has to include a designated use. So that water body you have to kind of define that water body as like, I'm going to use it for recreation, I'm going to use it for water supply, drinking water supply, or for aquatic life, right? So your water quality standards are based on how you define it as its designated use. And then your criteria. So we do a lot of math in this class to kind of figure out like, this is where the focus is going to be for like your biotic ligand model for the criteria, the numeric, pollutant specific, and narrative criteria to protect the designated uses. So this is just an example of like EPA's water quality criteria. So you can find this table. I think I included the link later, but it'll have like, here's your pollutants, right? And then path number. And then you'll have like an acute value, right? A chronic value for fresh water, and then acute and chronic for salt water. And then this will kind of give you like, so these are, you'll see like numbers, right? These numbers are typically based off of like, you'll find your LC50s, right? They're based off of that, and then your acute to chronic ratio. But for the biotic ligand model, for example, you'll see, so for fresh water, it's just a line. For salt water, these numbers are still based on your, like, just straight tox data. But it'll tell you here, freshwater criteria is calculated using the biotic ligand model. So when you click on this copper thing, it'll give you like a bunch of documents that say we're using the biotic ligand model. This is considered our water quality criteria. And it's super complicated, right? So implementing something like that in a permit gets even more complicated. But we'll talk about that in a second. So, Section 301 of the Clean Water Act and 122.44 of the CFR say that limits have to be derived. Your limits, your numeric limits, have to be derived from and comply with all of your water quality standards. So, I'll give you an example of that in a second. And they have to be consistent with the assumptions and requirements of any available wastewater allocation and EPA approved TMDL. So, you guys are all familiar with TMDLs and wastewater allocations. Okay, so basically EPA usually, when it's an impaired water, EPA will kind of say you can only discharge this amount into this water, which is your total, well, it's actually your wastewater allocation per facility, but it's established, it's based on your total maximum daily load, right? So that's your TMDL. I really don't know that much about them. I need to learn more about them, but it, somebody that's way smarter than me does a lot of math to figure this out. And it's based on how many discharges you have into that water body. And also so it considers point sources and non-point sources. And each point source is allowed WLA, so wastewater allocation. And that includes stormwater, which to me kind of blows my mind. And then you have your non-point sources, which they'll account for. How they account for all that is still a mystery to me, but still learning. So your water quality criteria will apply in the receiving water and can include magnitude, duration, so I can't really think of a good example of that right now, but yeah, it'll describe all of that in the actual documents. And then your effluent limitations, those apply end of pipe, right? So the pipe that's discharging into the water, that's where you have to take your sample, and that's where your effluent limitation applies. Your ELGs apply. So that's usually you can only have 50 micrograms per liter of whatever pollutant, and you can also there's different averages set in the ELGs, but we don't really we do have to, sometimes the ELGs don't necessarily line up with our benchmark monitoring, so there's a lot of program that we have to do to figure out which one's more stringent, but those are all set forth in the permit.
Yeah. It's a good question. The 2 slides before this, when you said they have designated water users, the water supply with the aquatic life. Is the aquatic life then the lowest kind of least stringent?
Not necessarily, because it depends, it really just depends.
Well, compared to the recreation.
Yeah, I think that it really just depends on what your water is, and if you've got a lake that you've designated for for fishing, right, for aquatic life, you got a bunch of people that fish there, they're gonna be pissed off if your fish are all dying because somebody's just discharging a bunch of copper into it, right? So it's not necessarily the least stringent. It really just depends on the receiving water body and what's going into it, and realistically how involved the public is and how invested they are. So, and that varies by state, by county. It's just there's really no way to say which is the most. And so for example, water supply. I had somebody reach out to me recently that so if you're talking about drinking water supply versus aquatic life, right? So in this case, their drinking water copper limits were way higher than our water quality criteria for fresh water or for salt water, right? But why? Because copper is way less toxic to humans than it is to fish, right? So like his argument was that he should be able to discharge like higher levels of copper. His argument was solely based on the fact that like the water coming out of his hose had higher copper levels than like what he's allowed to discharge. But his rationale was like not legitimate because that's not the point of benchmarks or for the aquatic life criteria. I don't know if that answers your question. So here, this is actually way more applicable to like individual permits, but I just kind of wanted to give you guys an idea of individual permits before I jump into general permits. So, and how they're set up. So they'll set up you gotta figure out how much flow is coming out of your effluent, right? And then you kind of figure out generally your pollutant concentrations, right? And then you will look at, you all at the same time, you look at your receiving water conditions. So your receiving water flow, your background pollutant concentrations, your hardness, and then other receiving water characteristics. So for the biotic liquid model, it requires various inputs. And so you kind of have to have an idea of the characteristics of the water into which you're discharging before you can kind of have any idea of how the pollutants will affect it. I think that we've all learned that in this class. So the critical conditions, like when you're defining your critical conditions, those might depend on when the impacts are expected to occur. So we learned that in Laura's paper that a lot of times the things that are happening vary depending on your weather, right? If you're in dry conditions, then there's one thing that kind of dictates the stability. If you're in wet conditions, it changes, and there's something else that kind of dictates the stability and the concentrations of these could be pollutants in water, right? So for an individual permit, they would probably address that and consider those critical conditions. So WQBLs are water quality-based effluent limits. So you kind of have to decide whether or not you need those water quality-based effluent limits. So if you need numeric values, or if you can just get away with TVLs, right, the technology-based effluent limits. So when a permit writer would need to establish effluent limitations using water quality criteria, they have to be established in permits to control the pollutant parameters that may be discharged at a level that will cause or have reasonable potential to cause or contribute to an excursion above any state water quality standard, including the state narrative criteria. So when we talk about a narrative criteria, you might hear fishable, navigable waters. So that's something that it doesn't necessarily have a number tied to it, but you have to maintain it so that it's fishable and navigable, right? So you can't dump a bunch of trash in there because then the boats can't drive through it easily. And you can't dump a bunch of copper in there because then the fish die. So those would be an example of a narrative criteria. But here you kind of you have to have a certain limit, right, to tell you when you're reaching that point of when it's no longer fishable or navigable, right? So that's really what these water quality standards are, and what your limits are based on. So for an individual permit, usually they'll conduct a reasonable potential analysis that's based on numeric criteria. So that's 100 milligrams per liter, blah blah blah. We'll talk about where that number's come from in a second. And then their narrative criteria, sometimes they'll use a numeric interpretation, sometimes it's more qualitative, through fishable and navigable water kind of thing. And then you can do this analysis with effluent data or without actual effluent limitation, effluent data. So like, say for example, you are a new facility, right? And you kind of have like what your effluents are designed to be, but you don't really have an idea yet. And so you can use data from other sources or other like similar discharges or other facilities around to kind of get an idea of that. And then, so there are some other like considerations in writing a permit. So the Clean Water Act has basically like restricts us from writing a permit that is less stringent than a previous permit. So this has come up in state permits too, and in ours. But like, say for example, so actually, this was really kind of interesting. We changed our aluminum benchmark this go round, and our benchmark is actually higher than it used to be. But that was based on like the aluminum water quality criteria. So we kind of went back and forth with this anti-backsliding, anti-degradation. They're similar, but they're different. It's basically the idea that like, you know, the 2026 MSGP can't be less stringent than the 2021 MSGP. So it's the idea of that you are actually eliminating like pollutants in your discharge. That's the whole purpose of the ENCE program, right? So the state anti-degradation policy may restrict or prohibit new or increased loadings of pollutants to high quality or outstanding natural resource waters. So a state can define, say like this water body is a high quality or outstanding natural resource water, and then all of a sudden like there are extra like restrictions to discharging into those waters. Or they can restrict discharges altogether from new sources, for example. And these are like, they'll be listed on like the state website. They're pretty clear. Well, you can pretty much find them if you're looking for them. And so usually for these permits, it's kind of like, we're coming at this in like two different ways, right? EPA doesn't have like enough inspectors to go out and inspect every facility, right? So a lot of this is we're requiring each facility to monitor on their own and to report on their own. So like, you know, a lot of this is beyond our code, right? So yeah, you're required to comply by this permit, but like, and the permit will specify the type. So like benchmark monitoring, you have to monitor every quarter, and then pH monitoring, you have to monitor twice a year. To give an idea, really what we use benchmark monitoring for is to make sure that your stormwater control measures are working, right? And that it just kind of helps inform what's happening in your facility. It helps you figure out whether or not the stuff that you've designed is working properly. So, facility. The permit will also establish like what data and supporting information must be reported. So like outside of monitoring data, for example, for aluminum and copper, we have provided for these facilities specific like benchmarks, so to speak, or levels. But in order to like use those options, there's a whole list of data that they have to turn in, right? And they have to prove, okay, like this is my receiving water body, water quality, and this is what I'm discharging. I'm not destroying the water into which I'm discharging, right? But the permit will tell you what you're responsible for reporting, so on and so forth, and then when and how the information will be reported. So we say almost always you have to, like, your monitoring results you have to put into NetEMR, which is net discharge monitoring reporting. I don't even know. But and then some, like rarely will we ask for like paper anymore, but it'll tell you how to report the stuff that we're requiring. Other conditions that can be included, like we talked about, you know, your narrative, so you have to include your best management practices, your BMPs, compliance schedules, right, additional monitoring, special studies, and then your standard conditions have to be in every permit. So here I'm going to switch into like stormwater. The permit that I'm working on is really focused on like this. So here you have like, you know, in a wet weather situation, right, when it's raining, you've got, say this is a facility. Like, this is a facility that has a bunch of like industrial activities happening. They have a separate like sewage treatment plant that like, you know, that deals with the sewage. But like for their stormwater, it all goes into a certain drain and then out into a water body. So there are really like 3 pieces of the like stormwater program. There's municipal, which are your MS4s, which like I can never remember. Municipal, separate, stormwater systems, MS4. There's 4 S's, but I can never remember what they are. So there's MS4, and then your industrial, and then construction. And this 40 CFR kind of tells you what you can and can't do within each of those, right? So here, my focus is going to be this industrial stormwater. So like for industrial, these facilities have to establish what's called a stormwater pollution prevention plan, and that kind of lays out everything that they plan on doing to comply with the permit for the most part. It lays out their stormwater control measures, like how often their employees have to sweep up so that all of the solid won't flow off into the water. It will lay out kind of the pollutants that could be exposed to stormwater, the pollutants that need to be covered, so on and so forth. And so this is, you've seen this before, but, you know, here, this is where we are here. We're talking about this permit. This is the 5th iteration. So like not long after the statute, the Clean Water Act was like put into law, they established the regulations surrounding that, and then they started writing a permit, right? So before that permit actually happened, they had a bunch of data. A lot of industries kind of self-reported like the pollutants that they thought that they would be responsible for, that they thought they would have to discharge into like the waters and so on and so forth. And a lot has changed since 1995, but realistically, the permit has like maintained its same like structure, and it's just gotten bigger, more monstrous. So the MSGP, which is the multi-sector general permit, it covers 29 sectors. So that's anything from like, you know, scrap recycling to mining to, you know, oil and gas to marinas, things like that. It's issued every 5 years. Sometimes we don't make that deadline, and things have to be administratively continued. And they also they'll allow for a no exposure certificate. So like if you say that all of your industrial activity, so mind you, for this permit, we're only regulating discharges that are associated with your industrial activity. So like we don't regulate the stormwater that's coming off the parking lot because there's no industrial activity happening in the parking lot. Now, you know, so for this exclusion, like if all of your industrial activity is covered and it's not exposed to stormwater at all, then you can submit what's called like no exposure certificate, and you don't have to comply with the monitoring and reporting and so on and so forth. But it's actually pretty difficult to do that. So, and then this MSGP only applies in those places that EPA has the NPDES authorization. So generally speaking, like for the MSGP, the whole point of the permit is to make sure that these facilities like control their discharge as necessary so that it does not cause or contribute to an exceedance of applicable water quality standards. You should be familiar with this. This is really like MSGP. So MSGP also like will cover certain oil and gas like activities in places in Oklahoma, some federal facilities in Colorado and Washington, and some in Delaware and Vermont. So to give you an idea of like what this permit covers, this is based on the 2015 permit. There were about 2,400 facilities that were covered under this permit over these areas. These are the different sectors that you'll see, like, you know, you've got chemical products, asphalt roofing, air transportation, so like airports, like the Reagan National will like, they have permits because they technically like discharge in Potomac, which is technically DC, which is under EPA's authority, coal mines, so on and so forth. So this is an example of some activities that like areas that would be covered in the MSGP. You know, anything that you can think of, like industrial plant yards, material handling sites, which you don't necessarily think about, but if you handle certain materials, then it has to have MSGP coverage or stormwater discharge coverage. Storage areas, things like that. So as part of the MSGP, you kind of have like, you have eligibility conditions, and then you have to develop your stormwater solution plan, right? So you have to say like, okay, am I eligible to apply for coverage for this? Like, are the discharges that I'm discharging only stormwater? Because as soon as they're mixed in with processed water, it's no longer a stormwater discharge, and you can't get coverage under this permit, right? And then you have to say like, okay, this is my plan, this is what I'm gonna do so that like I'm meeting water quality standards, right? Then you have to apply, you have to like apply for the permit coverage pretty much. You submit an NOI notice of intent and kind of go through it, make sure that everything's okay. And then you have to install those control measures to meet effluent limitations. Well, in theory, those are already installed, but if based on your monitoring and your inspections, you find that like you're discharging more pollutants than you're supposed to, then you have to like consider installing additional measures. So these are the parts, like you can read it if you want, but 1 through 7 are pretty basic. Part 4 establishes like general monitoring requirements, and then corrective actions. So this was kind of new in this permit. These not corrective actions, but we like made this a little bit more stringent this time around. And then you'll have sector-specific requirements. So like that's what I was talking about earlier. You know, your wood facilities don't necessarily have to monitor the same thing as your mining facilities. And then this is part 9, the state travel requirements. That's what I was talking about. Massachusetts. Massachusetts has put in conditions in this part 9 that say like, okay, on top of the regular monitoring that EPA has set forth in parts 1 through 8, you also have to monitor for this and like in this way. So some changes that we made with monitoring this time around, like I think it's pretty interesting. I didn't realize this, but previously only like 55% of the facilities had to do benchmark monitoring. And some of those were based on sectors and what they like kind of self-identified as in 1995. And so since things have changed since 1995, this time around we're requiring the other 45 facility or 45% of the facilities to conduct what we're calling indicator monitoring. So they have to monitor for pH, COD, and TSS that kind of give us an idea of whether or not the next iteration of the permit we will need to like require additional monitoring for specific pollutants. It's really just meant to give us an idea as to whether or not like their stormwater control measures are working. So there's different types of monitoring, right? Benchmark monitoring, effluent limitation monitoring, and then impaired waters monitoring. So benchmark monitoring if you exceed your benchmark, it's not a permit violation, but failure to take action is. Effluent limitation monitoring and exceedance is a permit violation, so like there's additional things that you have to do if you exceed your PLGs. And then your impaired waters monitoring, this is like, it's not as stringent as I like it, but you pretty much like if you're discharging into impaired water, then you may have to monitor for additional pollutants that are causing impairments, even though they may or may not be associated with your industrial activity, just to be sure that you're not contributing to additional impairment. And then based on those monitoring results, right, you may or may not need to take corrective action, right? So for benchmark monitoring, if you're exceeding like really high, then you have to install some sort of infrastructural like stormwater control. So like maybe you have to put in a retention pond or some sort of technology that can filter out the metals. Who knows? Whatever your facility, it really depends on your facility. So this permit does not dictate what BMPs and what SCNs are like required, because it's super like up to the facility and what they're monitoring for and what their industrial activity is. So usually the first round will say, okay, review your plan, what's not working. If this isn't working and you still are exceeding, then you have to like do something else besides like review your plan. And then if it's still exceeding, then you have to implement these infrastructural controls. So this is really just an idea of like what they have to include in their plan. And then their reporting requirements, so they have to like get the NOI, change if anything changes, like in their facility, say they add like this whole separate sector which has a different industrial activity, then they have to like report that. If they are shutting down or they no longer need coverage, then they have to report it in notice of termination, and then every year they have to report the annual report. Like I said, sector-specific requirements, state and tribal requirements. This is just an example of like our public comments that we received on this permit. You can see that the majority of like what we hear from are trade associations for the industry. So go comment on our permits.
Academia is not very involved.
Yeah, they like. I don't know if we actually like put them out specifically. Yeah, they 0%. So go comment on our permits. We actually do like. I think people are surprised to hear that we do take into consideration a lot of the comments. So that what's called the additional implementation like measures, it was originally designed differently, and then based on public comment, we had to like redesign it. And I can't remember if it was the NRC study, maybe it was a combination of the both, but NRC study and public comments was really the push to include the biotic ligand model option in this permit. So, and oftentimes like people will like through our public comment like process, they'll give us data, right? Data that we may not have known existed, or like we wouldn't have seen otherwise. So it really is like, it's very frustrating because you get comments from all over the place, but it is really an interesting like kind of place to work. So I'm gonna switch in like the last 20 minutes, 10 minutes, to kind of talking about metals and controlling metals based on the permit, right? So we've been talking about metals in this class for a while now, and for me, in the context of a general permit, metals are like the notoriously difficult to write into a general permit. So I should have taken a screenshot of what our benchmarks look like, but I'll give you an example of that. Normally our benchmarks are just like, 5.19 micrograms per liter. That's what you have to be under. Like, if not, then you have to implement these additional actions, right? But for metals, that doesn't necessarily make sense. For TSS, maybe it makes a little bit more sense. But for metals, because like metal toxicity is so dependent on your water quality and the characteristics of your receiving water, like we have kind of taken a step back from like just requiring one, like it being under one line. And initially, we still, for many metals, require benchmarks based on hardness, right? So hardness will give you a better indicator than just like one line based on LC50s as to whether or not the amounts of metals in the water are toxic. They're naturally occurring, but like they're not always bioavailable, right? So, and I'll talk some more about that. They have complex chemistry toxicity. So, I mean, we've learned about kind of metals like, they bind to this and they bind to that, and like everything changes, right, based on the water chemistry. So they and then like in Laura's paper, we talked about how between winter and summer, right, like everything that's in the water and like what it does is, is different, right? So we, like I said, we had addressed some water chemistry and metals bioavailability by adjusting to hardness. But the hardness equations, like those account for variations in pH and alkalinity maybe, but it doesn't consider other water quality chemistry parameters. So, for example, you'll see in the biotic ligand model, the dissolved organic carbon is a very important, and we talked about that in Kashi's presentation, right? Yeah. How like the dissolved organic carbon concentration is very important, like in defining bioavailability of these metals, right? And so the hardness-based water quality criteria doesn't necessarily reflect like the effects of the water chemistry on metals bioavailability. So I think to understand why this matters, I think you kind of have to have an understanding of risk. And so for EPA's purposes, you can usually say like, the aquatic life criteria is based on the amount of the chemical that can be present in the surface water before it's likely to harm plant and animal life. So that's really your risk picture right there. That's the definition of risk. Well, okay, let me go back. That's like really the definition of like kind of your water quality criteria. So they'll design their water quality criteria based on that and based on like what's usually tox data. But in order to define risk, you have to have exposure and hazard. So usually your hazard is kind of the tox piece, right? Your LC50s, it says like you can add up to this much before you kill half the population, right? So we don't want to add that much. We don't want to kill half the population. So we establish water quality criteria. But when, in a lab, when they're adding so much of this certain pollutant to water and saying like you can add so much like until you kill half the population, those are under very specific conditions. And they're not allowing for the fact that the bioavailability of those metals changes when you're under different conditions, when you have a different pH, when you have a different DOC. So like normally in a lab, sometimes they will add like DOC or like something to like to represent that, to figure that out, right? But like, it's not necessarily apples to apples, right? So when you go out into like the real world in, you know, a regular water body, then you have varying conditions, right, between winter and summer, right? So to account for that, they have started using things like the biotic ligand model, which is based on, let me come back to that. So they actually, EPA has established the wildlife freshwater quality criteria for copper based on the biotic ligand model. So it's a model that uses the receiving water body characteristics and monitoring data to develop site-specific water quality criteria. And the input for this, so it's a little bit more difficult in like the general permit because nobody really wants to monitor for anything more than they have to. But for a biotic ligand model, in order to establish this site-specific water quality criteria, you have to have like many data points for pH, VOC, cations, your anions, alkalinity, things like that, and you have to put them into this model. So like, why does that matter, right? So like, we have learned that, well, we've learned about like competing ligands, right? So you've got your metal here, right? And really what kills the fish is when this metal attaches to the fish. The fish is gonna be the ligand, right? So when this metal attaches to this ligand, right? But it doesn't always do that. So like, just because there's this much metal in the water, which is usually what you get from your lab, right? That's what our monitoring results give us. Dissolved metal, dissolved copper, right? But that doesn't necessarily tell us like what's happening in the water. So like, that metal could be attached to like carbonate, it could be attached usually to this dissolved organic matter. And then on the opposite end, like, you know, you've got this ligand, right, that is competing these cations. I get this confused. These cations are also competing with this metal for attaching to the ligand, right? So like, the biotic ligand model accounts for all of those things. And
Sure, quick question. So, like, in the previous slide, so you say that there's a WQC for copper that is based on the biotic ligand model, but there's also like different input data for BLM. So, I was wondering how they get that specific number.
so that's the thing is, well, we'll get there,
Okay.
but it's not necessarily one specific number. That's the thing. Like, you have to, in order to like kind of find your number, you have to know all of these numbers to plug into like the model to kind of tell you like how much free copper is available in a sense to like append to fish.
Yeah.
That makes sense.
Yeah, that makes sense to me, but just wondering why, because I couldn't find like the software to do that, to like input the numbers into it, and then I can get a like BLM based WQC. So I'm just wondering why EPA just published one WQC values on their website instead of providing the software for like the public or like others to like.
So I think that the software, like, I don't know why, but I have the software and I can send it to you guys if any of you want it. I had to ask a coworker that I was working on the permit with on these things, for him to send it to me. And his name is actually on, like, you kind of have to dig for it. So EPA is not known for web design. I'll say that. You kind of have to dig for it, but his name and his email address is listed. It says, like, I forget exactly what it says. His name is Luis Cruz. And if you email him, say you're interested in, like, the model, he'll send you the model. And it kind of, that's actually what some of these, like, examples are based on, like the example data set that's in the model. But for fresh water, right? So this is only developed so far for fresh water. They're in the process of developing this and like kind of a bigger general meiotic ligand model for all metals. But that's a whole big thing that I'm not really a part of. And I mean, we're already like 30 years behind in trying to put this into a permit, so general permit. And it's really hard. So, but it's not really like, you'll see one number for saltwater, basically because this is not developed for saltwater yet. And in our permit, we have one number that you'll see in a second, but that number is actually based on like kind of an average of an average of an average of the nation's waters and the biotic ligand model. So they took, somebody way smarter than me took a bunch of data from all of the waters across the United States and said like, okay, this number should be protective of 95% of the fish in the water, which is pretty normal for like 95% protection. But I don't know if that answers your question or not.
Yeah, because when I was trying finding the WQC values, and let's say based on the BLM, I'm like, oh, that's a link. Maybe I should click on that to it, and then it just give me like reference menu. I'm like, so where's the actual software?
Yeah.
Like I kept like looking into it, but it's good.
Yeah. I'll send it to you. And if anybody else wants it, let me know.
In response to her, there's one PDF file which has like a huge table and they have like different info and one like like one final value for different values. They have it somewhere.
Oh, okay. They have it somewhere. I just have to like find it.
Yeah, it's hard.
I think that there are like private companies that have taken this model and probably made something like a lot more user friendly. That happens all the time.
Yeah, a lot
That's-
of consulting firms,
you know.
they just have it in a much better platform than what they use. The main limitation for these models is to have the right equilibrium constants. To put
Which
them
is
in.
way more difficult than you think it is. But I'll send it to you. So fish, there's all these competing ligands, right? And then like competing cations for the fish ligand. And then this is kind of just a graphic of like, you know, so CCC is your, I have to remember all the time. It's one of your water quality criteria, the chronic one. So like it'll tell you, here's your hardness based, like chronic, like kind of use endpoint, it's more like human health, but like chronic endpoint, chronic water quality criteria, right? And that like, so mainly, like you can see the differences between like the dissolved copper based on your meiotic ligand model versus your hardness like based, right? So that just kind of tells you that like something is like out of really alignment. So they like it tells you like, you know, it's not accounting for something. So the hardness based like water quality criteria don't account for your pH or your natural organic matter effects. So your water quality criteria based on hardness, like based on hardness, can end up being either overprotective or underprotective, or you know based on seasons, like both different times. So did this out of order, but where are my other slides? Where'd they go? Oh no. I don't know what happened. Did I miss them? Oh, here we go. Okay. So this was totally missed this. So this right now in the MSGP, this number, this 5.19 micrograms per liter, is what our benchmark is currently set at. And I think there's some other slides. Yeah, so like this is like a real life example. There's a marina in Massachusetts that, granted, they're discharging to saltwater, so like just kind of forget about that, but their monitoring results show that like they have 1,200 micrograms per liter of total dissolved copper. So what does that mean? Our benchmark right now is 5.19 micrograms per liter. Like that would require a huge removal rate, right, of copper in order to achieve that, right? So like basically they're gonna have to like implement all of these infrastructural controls, right? And it's gonna cost a lot of money. It also could cause more pollution. And that's not really, for them, that's not like super realistic, right? It could be, but like, you know, what they want to know is whether or not they're actually like contributing to the degradation of the receiving water body, right? So, you know, if you just choose one number, right, to compare that to, and that's incredibly difficult, right? But if you were, so I did the math in here, but like if you were to like kind of say like, okay, establish a benchmark. Well, this is the benchmark for, if you say like the hardness benchmark. The hardness of your receiving water body is between 100 and 125 milligrams per liter. Some carbonate. Did I do this? Where'd it go? This is out of order. I changed this morning. Clearly. So we have this table in the permit. So this is your hardness. Not very well defined, but and then your copper benchmark value based on this hardness would be 0.0156 micrograms per milligrams per liter. So that for them to be under that benchmark, it would require an 8.7% removal rate. So they want to know kind of like what would be more realistic benchmark, so to speak. And our benchmarks are pretty much like right in line with the water quality criteria most of the time, which some people can argue about because it doesn't necessarily allow for like dilution calculations, but it also like is like less conservative in other ways, right? So if you use the biotic ligand model for this, like your new benchmark is actually 34 micrograms per liter, and which, you know, you'd have to remove a little bit less, but that target is a little bit like higher, right? And this, so this is kind of, these are my calculations. Sorry, it's all handwritten. I didn't have time to put this into Word. But these are my calculations for basically just straight water, right? So like this water, this number I got from like the data that in this Kansas River, like at sample data for the biotic ligand model, just so we can kind of compare. So really, then down here, like, so realistically you would get this CU total, right? That's what your lab is going to give you. And then you kind of like have to have an idea of your free copper, right? That would be available to the fish, the tend to the fish. So this matters in these equations. So here I kind of set up like two different mass balances, right? So like here's your copper total, and here these are your like ligands, right? So like you've got two like kind of competing things happening. So in your copper, you've got, you know, the free copper hydroxides, you've got the copper that's attached to your sulfates, chlorine, carbonates, and then your salt organic matter. So I tried my hardest to calculate like this based on like these hydroxides and just the dissolved organic matter. I couldn't find a K. Like
the paper I sent you from ENCE yesterday.
So the K, there was a paper that she sent me, and there was a K. Actually, I don't know if I hit the slide or not, but the K like varies
As a function of the BLM.
as a function of the ratio of copper to DOM.
Yeah.
And so I tried, like, basically I found that, like, for this example, that ratio was, like, way on the left side. So it was a lot less copper than DOM. And so my K was, like, my log K was 20. But then when I plugged that in, I ended up with, like, massive numbers for, like, for this term, for the most part. And, like, it didn't really make sense to me. So I felt like I was doing something wrong. And I crumpled up my piece of paper and was like, I'll just put these equations and explain it, like, qualitatively.
That's fine, we can look at it.
Okay.
We'll make a phone call out of it.
Okay.
No.
Sorry, guys.
We'll make a phone call out of it.
But you can see that, like, you know, if you have a hardness-based, like, water quality criteria, it might account for all of these, and, like, maybe your carbonates, but, like, realistically, there's a lot of this happening, and you'll see that in the results in the biotic ligand model, right? There's a lot of this happening. And then you also have, not only do you have, so you get this number, right? But that's not really, like, you know, indicative of, like, how toxic it is. And so you also have, you know, your, like, these other things that are competing for the ligand site, right, on your fish. So when you take all of that into account, the amount of dissolved copper that the water can withstand before becoming toxic, before adverse effects, like, start happening, is way higher than it would be based on just LC50s in a lab with, like, just strict water when you're just accounting for, like, this, right? So that is really the importance of the biotic ligand model here, and really for, like, metals in general. And you can see, like, you know, as this goes up, if your total copper, right, is one number, if this goes up, then this goes down, which makes it less toxic, essentially. And then, like, here, right, if, like, all of your fat is taken up, well,
no, in the last one, if calcium goes up, then there is less L available to interact with the copper. And the calcium is not toxic, the copper is.
So you can kind of, like, you can get an idea, like, just looking at the mass balances, of, like, what's competing for what, and kind of your relationship as, like, certain things increase and certain things decrease. So why does this matter, right? Like, your discharge limits are set to protect aquatic life, to restore and maintain the chemical, physical, and biological integrity of the nation's water, right? That's what the NPDES program is, that's what the Clean Water Act dictates, that's what I'm doing on a daily basis-ish. And so, in order to do that, you really have to kind of, like, have an understanding of where that line is in which the waters would be affected. So the biotic ligand model gives us a deeper understanding of, like, you know, the actual toxicity of the copper, the dissolved copper, based on the conditions for the receiving water body. I think there's a lot more work to do. I'm gonna give you guys, I'm gonna go really quick because we're already over time, but you can, like, read through this. These are, like, kind of your tox values. That's essentially what the biotic ligand model spits out at you. They'll give you a final acute value, and that's what you would compare. It'll give you a final acute value. Really what we use to, like, regulate for the most part is this, which is your final acute stormwater. Your final acute with, like, a safety factor, so to speak. And so these are the numbers that it'll spit out. And that's what you would compare your, like, monitoring results to. Like, are my monitoring results less than this CMC listed here after I ran my model based on the conditions in my receiving water body? And that would be kind of, we offer that for the general permit, But we haven't seen that yet, so stay tuned. These are just like, this is also an example of the results that it spits out. You can see like it'll give you dissolved copper, free copper, organic copper. I don't really know the definition of all of these. I mean, you can kind of guess, right? Biotic ligand copper, biotic ligand copper hydroxide, those are things that would be like attached to fish, maybe. And then like these results. So what I ended up doing was kind of finding the 95th percentile of these numbers. That would be more realistic. Like we don't really change the benchmark on a quarterly basis. What we would do is we take 1 year's worth of data for this facility. We would find, you know, basically you can't go greater than this. So like, yes, it gives you a little bit more wiggle room as to what you can discharge, but like, we still have to have like minimum number here. And this is just kind of like how your like your CMC changes with like seasonally. So based on all the other things that we learned in this class, health presentations, it makes sense, right? And here's some resources for you guys to look at this presentation. This is you know, where they're actually discussing kind of expanding the biotic ligand model to all metals, and they're working on that. Kind of interesting. Here, this Water Quality Standards Academy is something that EPA offers. You can sign up for like the listserv or whatever, and training. This time it filled up in like less than 2 hours. And then they also have a permit writers course, which is really interesting if you want kind of an idea of like, it sounds really boring to be a permit writer. I never thought that I would end up in this place, but it's really way more interesting than it sounds. And like applying these water quality standards to like permits is incredibly interesting and challenging. So I know we're out of time, but if you guys have any questions.
Any quick questions? Okay, well, we'll look at the presentation, we'll post the presentation. I got the BLMs from you guys, the video presentations, we'll look at that. Maybe later on, after the second exam, we'll spend another day talking about the biotic ligand model, okay? Because yeah, the most difficult part, yes, there was room for an hour, otherwise we're trying to find equilibrium constants. The most difficult part is to find the right equilibrium constants to kind of convert it in a homework type exercise. A lot of labs, a lot of people are looking at citrate, titrate, different amino acids to find equilibrium constants. But it's hard to find a BLM because BLM changes.
And you can just end meeting. Yes, and yes.